Hello, this video will be about something called completing the square, and the video will go along with the handout that I gave you in class. If you've misplaced it, it is in your student documents folder. So the first thing I want you to just do on your own, pause the video and factor the following perfect square trinomials. So pause now and factor A, B, and C. Okay, hopefully you pause like I said to do and check your answers with mine. I'm hoping you're seeing a bit of a pattern here. We'll talk about that in question 3. But the next question, number 2, is what would these look like if you used area tiles? Would it be a rectangle or a square? And then go ahead and just take one of them and draw it like you would with tiles. So pause the video and do that on your own. Okay, hopefully you paused that before you saw my answer. So because these are perfect square trinomials, you should have had a square, and hopefully you remember that from our work with the tiles. I picked the one that was x squared plus 4x plus 4, and you can see mine looks like a square. Regardless of the one that you picked, it should look like a square. Okay, let's move on to number 3. Looking back at number 1, seeing if we notice any patterns. So if we call the way to factor this x plus p squared as how to factor these perfect square trinomials we've been working with, we want to look for relationships between p, a, b, and c when using the standard form. Now notice right now I'm really talking about when a equals 1. The examples I gave were when a equals 1, so that's in general what we're talking about right now, okay? So look back up at your sheet, right? We had x squared plus 6x plus 9, and we said in factored form that was x plus 3 squared. So in this case, and I'll put a 1 there, that's A, we have B, we have C, and that's P. Okay, here's another one. We had 1x squared plus 4x plus 4. We said that was x plus 2 squared. So this is A, B, C, and the 2 is P. Okay, and then finally we had x squared minus 12x, minus 12x plus 36. And that was x minus 6 squared. And same idea, we have A, we have B, we have C, and that was P. So go ahead and pause the video, and I want you to see if you notice any patterns. And if you do, see if you could start writing some algebraic equations to state those patterns. So pause and try that on your own. Okay, I've erased 2 of them just for space on my screen. So I'm going to mostly talk about the first one, but hopefully you'll see these patterns held true and you came up with some similar things. When I compare, sorry, I accidentally had on my eraser. When I compare C and P, one of the things that I noticed in all of them is that C equals P squared every single time. Could we then also say that P, so when factoring, is going to be the square root of C? Okay. Next, I compared B and P. Okay, here, I'll do that. Actually, let me do that in a different color. Might make it easier to see if I do it in a different color. Okay, so we'll compare B and P. And when I look at B and P, I see that B is double P. So again, if I'm trying to find P, because I'm trying to go to factored form, P has to be half of B. Okay, so if I'm trying to factor something like x squared minus 18x plus 81, and I think it might be a perfect square trinomial, I want to find my P, that would go here, something that's the square root of C, but also half of B. And in this case, it'd be negative 9. Okay? So that works every time. Another way we can think about this, if we combine some of the equations we've made doing a bunch of substitution, right? If I combine C equals P squared and P equals B over 2, another thing I could say is that C has to be half of B squared. And then that's also true because I can see my C here, 81. Well, half of B is negative 9. Squared is positive 81. So I can see all these relationships holding. And then finally, I'm hoping, and if you didn't get there, just write it down now. The last relationship we would want to notice is I could write this as x squared plus bx. So I'm doing a lot of substitution, plus b divided by 2, quantity squared. And that equals x plus b over 2, the whole thing squared. Okay? So I got there through substituting a lot of the relationships that I created. So you want to make sure you understand all these different little formulas I've written here and how I substituted to get each of them. Okay, and you may want to pause and kind of take a look at that before going on to number 4. All right, looking at number 4, I ask you, is x squared plus 8x plus 8 equals 0 a perfect square trinomial? Let's think about what we just determined about B and C, and can you figure out P to factor it? You might want to flip back over and look at those equations you just made. Okay. So let's try doing it with the tiles to see if we can do that. So if I go here and I start doing my tiles, and I go, okay, there's my x squared, and if it's a perfect square, I got to have 4. Got to split the 8, right? The 8x. So I have 4 on each side, and now I'm going to fill in my little ones. That was with the darker blue. So I've got 1, 2, 3, 4, 5, 6, 7, 8. Was I able to get a square? I am not able to get a square. What's missing? I'm missing 8. But am I allowed to just add 8? Like, are we allowed to just add 8? You cannot just add 8. That would change the equation. So what I could do is, I could do x squared plus 8x plus 8, and then add the 8 and subtract the 8 on the same side so that I've just added 0. Or I could do x squared plus 8x plus 8. That's my original equation. Add 8 on one side and add 8 on the other. Okay, but I have to have a net effect of 0. We're typically going to use this one here. Okay? So now let's look at how would we actually complete the square to solve for 8. Okay, so I'm missing an 8. So again, I'm going to use this one here. So I have x squared plus 8x. And then my original was plus 8, but I'm missing something. So I kind of like leave a space there and leave a space there. I'm going to add my 8 and subtract my 8. So that I get x squared plus 8x plus 16 minus 8 equals 0. This is a perfect square trinomial, so that's x plus 4 quantity squared minus 8 equals 0. To solve, I'm going to add 8 to both sides, so I get x plus 4 quantity squared equals 8. And now I'll take the square root of both sides. This is key when you're taking a square root of both sides and you have that variable x there, just like we talked about in the imaginary number video, I'm going to have plus or minus. So what I get is, because I'm taking the square root of something squared, it's just x plus 4 equals plus or minus square root 8. Okay, I'm going to erase a little bit so you can see my next steps from there on the same page. Now, I've got x plus 4 equals plus or minus root 8. I just subtract 4 from both sides, so x is negative 4 plus or minus root 8. However, this 8 can be simplified. That's actually 2 root 2. So x equals negative 4 plus or minus 2 root 2. And that would be my answer to this problem. So that's how I complete the square to solve a quadratic that would not otherwise be factorable. X squared plus 8x plus 8 is not factorable on its own. So I forced it to be factorable by completing this and making this a square up here, I had to add 8, but over to the side, it's like I subtracted my 8 over here, right? So that it would be an even thing that I did to the equation. Okay, last little bit. What if A is not 1? And we want to complete the square. It's a little trickier. So I'm going to go through this step by step. Remember that, well, let's start this. The first thing you want to do when A is not 1 is you want to factor out the A, okay? But you don't have to factor it out from C. You just factor it out from A and B. So let me show you what I mean. I'm going to factor out 3 so that I get x squared minus 2/3 x plus, I don't know, minus 1. Probably going to have to do something out here. I don't know, equals 0. Okay? So I let the minus 1 just kind of hang out there, and it's going to figure something out. Well, remember, to complete the square, we found out earlier that C is half of B squared. So my B is negative 2/3. So I'm going to take half of that and square it. So negative 2/3 times a half, and I'm going to square all of that. So that gives me, let's see, that's negative 1/3 squared. So it's 1/9. So I need to add 1/9. Here's the tricky part. The temptation is to want to subtract 1/9, but I can't because of this 3. If I distribute, really what I've added, 3 times 1/9 is 1/3. So to offset it, I subtract 1/3, not 1/9. I now have a perfect square trinomial here. So it's 3 times x, it's going to be a minus something squared minus 1 1/3 equals 0. So what's there? What's that p-value? Well, I don't know if you remember from what we did on the other side of the paper, but we said p is just b divided by 2, which didn't I do that back here? So p is just 1/3. Okay? So it's now factored. I've got to do some work to solve. I'm going to erase a few things so I have some room. First thing I'm going to do is add, this is basically negative 4/3. I'll add 4/3 to both sides. So 3 times x minus 1/3 squared equals 4/3. Now I'll divide both sides by 3, which is like multiplying by 1/3. So that's going to give me x minus 1/3 quantity squared equals 4/9. I have to take the square root of both sides now. So I get, sorry, don't know what happened there. I get x equals, x minus 1/3 equals positive negative square root of 4/9. I'm going to erase a little bit more so you can see what I'm doing. Next, okay, x minus 1/3 still equals plus or minus 2/3, because the square root of 4 is 2 and the square root of 9 is 3. Now I'll add the 1/3 to each side. So x equals 1/3 plus or minus 2/3. I can actually add those together. Okay, they have a common denominator. So 1/3 plus 2/3 is 3/3, and 1/3 minus 2/3 is negative 1/3. So the 3/3 becomes 1, and then my other answer is negative 1/3. So those are my two solutions that I found by completing the square. This is not an easy thing to do, but the process stays the same. The hardest part is that factoring out of the 3. We're going to be going over this in class on Monday after the long holiday, and so if you have any questions, make sure you write them down and bring them to class. Thanks.